As I probably explained in class at this point, I wasn't totally thrilled with the results from the Chapter 3 quiz, considering that pretty much everything on there should be a review of Algebra 1. In addition, it's all stuff that we've done in class, so it should be stuff that people, for the most part, kind of knew how to do, but had maybe forgotten. And we've seen lots of examples of these things at this point, so we should be great at these. This should be a test that everybody kind of cruises to at least a low A on. That being said, I didn't feel like the results looked that way. And so, we can't take that much time in class to review things that you already have a credit for in another class. That being said, this is also stuff that we have to know how to do backwards and forwards, and that's why we have, very, very tight constraints about, what test scores people have when they come into this course and that sort of thing. But anyway, we can't really deal with that at this point. We've got to make sure everybody's got the background to move on. So, trying to get as many examples out there that people can refer to so people get caught up. This is one of the two quizzes. I gave different versions in the two classes. The problem types are more or less the same, just different versions of the problem. So this might be the quiz you did, or it might be a variation on the quiz you did. Problem number one was a proportion problem. And most people did relatively okay on this. This maybe was not missed as many as some things. We used proportions a little bit earlier in the year. We briefly did some similar triangles problems. So this should be the second time in this course for proportions. Anyway, we know from fractions that anytime you have two equal fractions, the cross products are always equal to each other. So 1 times 4 is 4, and 2 times 2 is also 4. And that's an idea that you can use to solve these more complicated proportions. So I know that the cross products will be equal, and so I can multiply those out. I can basically set those equal. You can write this as 2 times the quantity 3x plus 1. I prefer just to multiply everything by 2 and not actually show that. So I usually just take 2 times 3x is 6x, and 2 times 1 is 2. And then set that equal to the cross product going the other direction. And same thing, technically it's 5 times the quantity 2x minus 3, but I prefer just to multiply both values by 5. So 5 times 2x is 10x, and 5 times negative 3 is negative 15. And from that point, we should be able to solve the equation and get this to work out pretty nicely. So I'm going to subtract 6x from both sides. I am going to, and that'll get the x's all on one side. So that'll leave me with a 4x minus 15 on the right, and that'll be equal to a 2 on the left. I can add 15 to both sides, and anyway, you'll see here that you end up getting 17 is equal to 4x. If x is being multiplied by 4, I can divide both sides by 4, and x is going to equal 17 over 4. Yes, that's 4 1/4. That's 4.25. We use improper fractions most of the time in high school, so I'd prefer you leave it in that form, although either of those other two answers would also be fine. And if you have time, you really should go back and check and put that answer into the original proportion and make sure that everything works out okay. All right. The second question on this particular version of the quiz was an equation solving problem. I think most of the people that missed this problem had a sign issue. It tends to be the sticking point on this type of problem at this point in the course. All right. So anyway, you need to distribute and get rid of your parentheses here so we can multiply through. 4 times 3x is 12x. 4 times 2 is 8. Okay. Now, for the second part here, remember that subtracting is the same thing as adding a negative. Okay. So I really treat that like I'm adding a negative 3, and I'm multiplying everything by a negative 3. Okay. You can handle it other ways, but make sure if you did it differently than that you got the right answer. If not, this might be the way you want to go. Negative 3 times x is negative 3x. Okay. And here's the kicker. Negative 3 times 4 is going to give you negative 12. Okay, then the whole thing equals 8. And at this point, we can combine our like terms and we can simplify some. You're going to get a 9x here. 8 minus 12. 8 minus 12 is going to be equal to negative 4. And anyway, on the other side, it's equal to 8. And we can add 4 to both sides. running out of room here a little bit, but anyway, we're going to end up with 9x is equal to 12. If you divide both sides by 9, you should be able to find out that x is equal to 12 ninths, which simplifies down to 4 thirds. Again, if you just have to write that as 1 1/3, that's okay. Please do not write it as 1.3 or any kind of rounded answer. But a lot of people had a plus 12 here, and if you missed that question, it's a pretty good chance that that's why you missed it. Maybe not why everybody missed it, but why a lot of people missed it. All right. Moving on to number 3. So we have this idea that the reverse of a square root is squaring something. So for example, if I have the square root of x is equal to 4, if I square the square root, that should just leave me with x. But if I square one side of an equation that has two sides that are equal, I also need to square the other side. And so we would find out in this particular case that x is 16, and the principal square root of 16 is in fact 4. Okay, so that's kind of the background. We need to do number 3, which has a little bit more going on. It's radical 2x minus 1 plus 3 is equal to 6. Remember, you want to get that square root by itself, but if you think back to Algebra 1, you don't have exponent rules for addition or subtraction. So you don't want to square the left-hand side of this equation right now, or you're going to have to square this whole thing. And the only way you can do that is to take that whole thing and multiply it by itself, which is actually going to end up being a really big and really nasty FOIL problem. And so, yeah, it is technically legal to go ahead and try to square the entire left-hand side at the start of the problem, but you do not want to have to work that out, okay? So the strategy that we talked about in class was get the radical by itself, okay? So you don't have any addition or subtraction or anything else going on there. Once you get the radical by itself, then you can square it, okay? Just like when you solved absolute value equations in Algebra 1, you got the absolute value by itself. And we're going to see later with problems involving exponents. If you get the exponent part by itself, then you deal with it. So anyway, just like most equations, add and subtract for your first step. So we're going to get the square root of 2x minus 1 is equal to 3. Okay, now this radical is the only thing keeping us away from the 2x minus 1. We can't change anything under there until we get rid of the radical. We're really moving backwards through the order of operations is what we're doing. So we're kind of peeling away the different things. X got multiplied by 2, then 1 was subtracted, then a square root is taken, then 3 was added, and they got 6. So we got rid of the 3. Now we're stripping away the square root. That'll get us to the 2x minus 1. So the opposite of a square root is to square. Got to balance it by squaring the other side. If you square a square root, those two things are going to knock each other out, just leave you with the 2x minus 1. And that's going to be equal to 9 on the other side. Add 1 to both sides, you get 2x is equal to 10. And it looks to me like x is going to equal 5. Again, if you've got time, I would stick the 5 back in there and make sure that that works. 2 times 5 is 10, minus 1 is 9. Square root of 9 is 3, plus 3 is 6. And we can see, yes, that really does work. All right, so hopefully not too bad on that one. All right, moving on. So the next one, we've got a fraction. We've got 2/3 times the quantity x minus 5 plus 3 is equal to 12. Again, one thing I saw in the quiz was people trying to take care of the fraction first. And, you know, technically you can divide everything by 2/3, or you can multiply everything by the reciprocal. However, if you're going to do that, you also have to multiply. Every term would have to be multiplied by 2/3. So you'd have to do it for this term here, you would have to do it for this term here, and you'd have to do it for that term there. And you'd end up with a bunch of fractions in the problem, which would be kind of messy. So just like most other equations you work with, you're working backwards through the order of operations. Get rid of addition or subtraction first. So we've got 2/3 times the quantity x minus 5 is equal to 9. Okay, now to get to that x minus 5, I don't want to distribute that and have a 2/3 x minus 10/3. Get rid of that 2/3. Okay, and we talked about various ways of doing it. The quantity is being multiplied by 2/3, so you can divide both sides by 2/3. You know, from whenever you learn to divide with fractions, what, 4th, 5th grade, something like that. Dividing by 2/3 is the same thing as multiplying by dividing by fractions is the same thing as multiplying by the reciprocal. So the same thing as multiplying by 3/2. I talked in class about the idea that if you multiply a fraction by its reciprocal, you get 1. So I would like 1 x minus 5 term there. So the way I usually think of it is I'm going to multiply this side by the reciprocal, and I'm going to balance it by multiplying the other side by the reciprocal. So 3 halves times 2/3 gives me 6 over 6, which is 1. That leaves me with just an x minus 5 is equal to, and that's going to be 9 over 1 times 3 over 2 is going to be 27 over 2. Okay, we add 5 to both sides. And 5 as a fraction, we need it in halves, right? So we're going to double that, and we're going to write that as 10 over 2. And so it looks like we're going to end up with an answer of 37 over 2, if I did that correctly, which I think is 18 and a half. So anyway, and I might want to check that before you go on, because that really, let's see, does that actually check out? Let's see, 2/3 of something gives you 9. Yeah, I guess it should be a decimal value. So hopefully that checks out. I don't have my original answer key here, but I think that looks good. All right, so let's go on to the next one here. And again, you can check my arithmetic on that, but the process should be right. Okay, question number 5, we've got squaring involved. And of course, squaring is the opposite of taking a square root. So when we're dealing with it in an equation, we have to deal with it the opposite way. All right, so same kind of thing here. Square roots, you might remember from Algebra 1, a square root's the same thing as taking something to the 1/2 power. And you don't know any exponent rules for addition or subtraction. So you do not want to take the square root of this whole thing, because we don't know how to deal with this subtraction here. Just like we did with the radical. We got the radical by itself, then we squared it. If we've got this squared term, we want to get the squared term by itself and reverse the squaring. We got to peel everything else away from it. So still working backwards through the order of operations. Somebody took a number x, they subtracted 3, then they squared it, then they multiplied by 2, then they subtracted 2, and they got 48. So we're going backwards through all of those steps, technically backwards through the order of operations. Last thing they did was to subtract 2. So we're going to reverse that by adding 2 to both sides. We've got 2 times the quantity x minus 3 squared is equal to 50. The next thing they did was the next to last thing they did was to multiply by 2. So we're going to get rid of that multiplication by 2. By dividing by 2, we're going to get the quantity x minus 3 squared is equal to 25. Okay, and this is kind of nice because 25 is a perfect square, which is kind of nice to see there. All right, so at this point, we've got to take care of the squaring, okay? The opposite of squaring is taking the square root, okay? But what you have to remember, anytime you have a quadratic, you have the potential of having 2 possible solutions. You need to remember, where am I going to get those 2 solutions from? Well, remember that there's a positive square root and there's a negative square root. If I ask you to take the square root of 25, you should tell me 5 times 5 is 25, so 5 is the square root, but also negative 5 times negative 5 is also 25. So the square root could be positive 5 or negative 5. So we're going to take the square root of both sides, but remember, you want the positive or negative square root here. Okay, so I really should be putting a plus or minus out in front there, and because we want the positive square root and we want the negative square root. So in the end, what's going to happen here is x minus 3 is going to be equal to positive 5, or x minus 3 is going to be equal to negative 5. And we have to solve both of those. So we get one solution of 8 when you add 3 to both sides. When you add 3 to both sides, you get negative 2 on the other one. And again, if you have extra time, I would stick that back in the equation and make sure that it really works out. Okay. The last of the equation solving problems, and I think I'm going to do the graphing in a separate video, is a literal equation. I ended up making this a bonus. We hadn't focused on this a lot, although really when we're solving equations in slope-intercept form, we're doing the same thing. So this was number 6. We had a equals 1/3 times the quantity mx plus t. All of that was being divided by b. Okay, and the equation asked me to solve for t. Okay, so I'm trying to isolate the t variable there. First of all, I would get rid of the 1/3. If you triple something, that's the opposite of taking a third of it. So I'd multiply this side of the equation by 3. I'd multiply this side of the equation by 3. 3 times a third is just 1, and so we end up with 3a is equal to mx plus t over b, which is good. I don't want to have a fraction here. I'm trying to get to t. Right now, this whole thing is being divided by b, so I'm going to multiply both sides by b. And I don't have a lot of room to do that there, but I'm going to get 3ab on the left is equal to mx plus t. And really pay attention to your units, to your operations here. T has an mx being added to it, okay, not multiplied by it. So I'm going to subtract an mx from both sides. And what that's actually going to leave me with is it's going to leave me with a t on the right-hand side. And it's going to leave me with it's actually going to leave me with a 3ab minus mx equaling t when we simplify this whole thing down. Okay, so that's what's going on there. All right, so I'm going to do a separate video to talk about graphing, and I will do that in just a couple of minutes.